to do that. Now, on the identities, what I've seen is the following. You are going to find identities with brackets. You are going to find identities without brackets. As you can see here, if you check here, you have certain identities which have brackets. You have identities which don't have brackets. Now, I wanted us to start with the identities which have brackets and say, how do we deal with the identities with brackets? Identities with brackets, you first work out whatever is inside the bracket. That's what you need to do. How do you work out whatever is inside the bracket? You are going to check these things that are inside the bracket. Work with them first. Work with them first. If there's a bracket, start inside the bracket and then you can go outside. Now, how do you work with things inside the brackets? Inside your bracket, the first thing that you are going to check is to check, do we have any of the identities here? Do we have any of these things? That's what I'm going to check. Do you have any of these things? If you have any of these things, you are going to change whatever is inside your brackets to represent if you have any of these things here. For example, if you had something like this, you have sine x, and then they say you have 1 minus cos squared x. Starting inside the bracket. If I start inside the bracket, I am going to say to them, okay, let me check my bracket. Is there any of the identities that looks like something inside my bracket? Do we have anything like that here in our identities? We do have that, and it's this part here. So that's where I'm going to start. So we have this part. Good for us. Then it means we are going to change this whole thing here. Instead of writing it as 1 minus cos square of x, we're going to write it as sine squared of x. So we can come and erase here and say, okay, but this whole thing here is represented by sine of x. So I come and write here sine squared of x. Then I can then multiply. This one multiplied by this one is going to give me the sine cubed of x, because that's how they work. They work exactly like the normal variables. It's like bases are the same. If bases are the same, we add the exponents. We don't multiply the exponents, but we add the exponent. So this is going to be our final answer here. Now, let's use that here. If we have the following, and then they say which we should simplify, let's check here. We have times squared plus 1. We have times squared plus 1 here. We have times squared plus 1. We don't have that. Now, since we don't have that, but we do have times square of theta. If you have times square of theta, you are going to change it and make it to be sine square of theta and cos square of theta. So it means in other words, you will have sine theta multiplied by the cos of theta, open bracket. You are going to have sine square of theta all over the cos squared of theta plus 1. This is where we are. So we've checked, and guys, this is a rule. This is a rule. If you see 10 and then you are simplifying or you are proving identities, change 10 to sine and cos, to sine theta all over cos theta. It's a rule, that one. 10 we're always going to change. So tonight we always want to work with the two trigonometric ratios. We want to work with sine and cos. Okay, now that we've done that, we are saying we need to simplify the bracket inside further. We need to make it a little bit smaller. Because now we've simplified it, but it's not that simple. So we need to simplify it a little bit further. Now, what do you have inside your bracket? You have a fraction and a non-fraction. You need to add these two things. So you have sine square of theta all over the cos square of theta plus 1. So we have something like this, actually. Now, when you add fractions, this is what you need to understand. If they didn't write anything, it means there's 1. You want to add these two things, actually. Now, if you're going to add these two things here, you should ask yourself, what is the lowest common denominator here? What is appearing here and then it's also appearing here? So the lowest common denominator that we have, we are going to take our LCD as cos squared of theta. Now, another way to think about this thing is that you can say it's similar to you having something like this. You have cos squared of theta, and then you say you have all over. Now, once you have your lowest common denominator, then you can come and say, here, how does this thing work? It's equivalent to you saying that you are going to multiply this thing by the cos squared of theta. Even here, you're going to multiply by the cos squared of theta. Now, if you say cos squared of theta multiplied by this, cos squared of theta and the cos squared of theta are going to divide each other out. What are you remaining with then? So we are left with sine squared theta plus this one, which 1 multiplied by the cos squared of theta. What do you get? Cos squared of theta. This is you now. What have you done, Balu? You've simplified whatever is inside the bracket. So it means I'm saying to learners, don't get out of the bracket first. Simplify the bracket. As soon as you simplify the bracket, then you can go outside. So you can come and say, I can write this thing as sine theta multiplied by the cos of theta all over. I have sine square of theta plus cos square of theta. Where does this thing come from? It comes from me adding whatever is inside the bracket. Okay? So here you're going to have cos square of theta. Then you close the bracket. Now, you are going to check your identities again. Every once in a while, you need to come and check your identities. In fact, you should be constantly scanning for your identity. When you look at the following here, it's this thing here. Cos square of theta plus sine square of theta, what do you get then? 1. Then you say, okay. It means I am going to have sine of theta multiplied by the cos of theta all over 1 multiplied by the cos square of theta. Now, if they didn't write anything on the denominator, it means there's the 1. Guys, we shouldn't confuse adding fractions and multiplying fractions. When you add fractions, you get an LCD. When you multiply fractions, it works this way. You are going to say numerator multiplied by the numerator, denominator multiplied by the denominator. And then if you do that here, you're going to get 1 multiplied by sine theta multiplied by cos theta, which is going to give you the sine of theta multiplied by the cos of theta. All over the cos squared of theta. But how do you get cos squared of theta? We said 1 multiplied by cos squared of theta. Okay? What is 1 multiplied by the cos squared of theta? It gives us 1 cos squared of theta. Now, it's equivalent to you having this. So you have cos squared of theta here, you have cos squared of theta, and then there's a multiplication. Can you see that? Okay? Then I can say, but now, these two things, they can divide each other out. Okay? Now, if these two things divide each other out, what am I going to remain with here? Sine theta, okay? All over. Huh? They divide each other this way. I agree you have squared here. If you have squared, remember, it's like if you have x squared, it's equivalent to having x multiplied by what? By x. If I have cos x all squared, it means in other words, I have cos x multiplied by cos x. Okay, let's come and rewrite this thing here. Instead of writing it as cos square of theta, we can come and say, we can write this thing as we can represent cos square of theta as cos x multiplied by cos x. Oh, cos theta, cos theta, all over 1 over cos theta. Anyway, then we can say that we have cos theta in the numerator, we have cos theta on the one on the denominator. What are we remaining with? If it's say this cos theta and this cos theta divide each other, we're going to be left with what? With cos theta. Go back to identity again. What is sine theta all over cos theta? Theta. And then you should come and do the following. Do number 2, and then do number 6, and then do number 8.